Hey everyone, how are we doing? It is a Monday. Oh my gosh, another week. We're on week 4 of school. Crazy. Hair's getting really long. I don't know. Maybe we'll just let it grow to my shoulders again. Hey, Cyrus. Is it Sawanris? Sawanris, some points in the chat for you. Got some Mondays here. We've got chapter 3 homework due tomorrow. Let's do chapter 3 homework. Good stuff. Preview. Javante. Got 2 people here, right? We'll do chapter 3 homework and get that done. Oh, man. I'm feeling so tired today. I don't know what it is. Drink a Coke. That's a right amount of caffeine, right? I shouldn't drink Coke. So much sugar in it, but I was so very nice. Thankful for the Coca-Cola. It's really helping me get that energy, get that sugar energy, all these things. Good stuff. Okay. Have you done chapter 3 homework yet, Javante? We're going to talk through it and do the work right here. I lost it somewhere in here. There it is. Let me get the timestamps going. And there we go. Well, let's go do it. We're at the 253 mark. Stat 201. Haven't done it yet, but yeah, let's do it. Thank you, Javante. Chapter 3 homework. Question 1. Here we go. So this is a contingency table. Take the note, a contingency table is a bivariate display of categorical. If you go this way, this is categorical Y. This way is categorical X. I'm blocking it, so I'll disappear for a moment. But contingency tables are bivariate, meaning 2 variables, displays of categorical. So what you're looking at here is whether someone is a U.S. adult or a president of a college. You can be both technically, but if you're a president of a college, we're going to classify you as a president of a college. So that means it's mutually exclusive. You're either one or the other in the category sense, and then how you view kind of the college education as a whole. And so when you're working with this, it helps if you have the totals. You can throw it into Excel and get some totals out of this. What percent of college presidents think higher education is a poor value? It actually tells you how many college presidents there are. There's 1040. So when it wants the percent of college presidents, we'll take a screenshot and show what we're doing right here. This is a conditional display because when we say what percent of college presidents, you'd have to go here and do out of the 1040. So 1040, think it's poor. So you take the poor right there and do that. So it's going to be about 2.5. Let's try that. Nice work. Okay. So the work is 27 divided by 1040. There we go. 2.6. I was wrong. Close enough. And with this, it was basically divided by 1,000, which moved the decimals around. Here we go. The next one. What percent of U.S. adults think it's either good or excellent? So 2132. I'm not going to be able to do this one in my head, am I? Or am I? Let's find out. Find out now on Stat 201. 2132, and it's a good or excellent. So we're going to add these and get 848. So when you think about it, this is like 2,000-ish, and that's like 800. It's going to be like 41.7%. We can find out the exact math. Let's take a guess. I was like guessing at these to see if I can get it. It's fun, and then you don't get it. And then it's not fun. So a little bit of fun. 848. Also, if you take a guess and you're way off when you do the calculator stuff, that's close enough. It's 39.8 when you round. We're taking these numbers right there and timesing by 100, so you move the decimals over. Once again, we're just dividing the sum of those 2 numbers, good or excellent, and dividing by. So 398. It's pretty far off on that one. See? Can't do it all. 39.8. There we go. As long as we read the questions right, we're good to go. Next one says, about blank percent of college presidents think that it's either good or excellent. Now, notice this changes to college presidents to see if there's kind of a relationship here. Because we said, what percent of the U.S. adults? It's 848 out of the 2,132. And it was 1040 down here. So we're going to do the same thing by adding these up. Already, that's a big number right there. That's 799 as far as I can tell. And that's the vast majority of it. So that's going to be close to like 79.2% or so. We're going to check the math here. But notice this is a much bigger amount out of this total versus the other one's a smaller amount because that's of the U.S. adults, these are all conditional, like of the U.S. adults, what percent think it's good or excellent? Of the college presidents, what percent think it's good or excellent? These are conditionals because you go within 799 divided by 1040. It should be very close to that. Very close. Let's check it out. I thought I'd get that one. So 768. Once again, just check your math. So if you notice here, given that someone is a U.S. adult, they are less likely to think it's good value versus college presidents, as we would expect. So on average, the college presidents tend to have a better opinion than the U.S. adults, and that is evidence of an association. This last question is not one of my favorites. It's just kind of a weird way of asking. It's asking 4.17% of U.S. adults think the higher education system is excellent. We can check their math. It's 101 out of the 2132, and it is about 4.74%. We can see right there. That is the 101 out of this. And as long as the sample is representative, we should be good. Therefore, it would be close to this. It's not exactly. If they take a good representative sample, then it should be about that in the population. It's not going to be exactly that, because it's like, imagine you're trying to figure out how much the average student spends on groceries a week, and you talk to a representative sample of 1,000 students, and you find, oh, on average, students spend $80 a week on groceries outside of their meal plan. Well, that wouldn't mean exactly that the college experience is spending $80. It would mean you have a good estimate of it. So remember, samples only give estimates. And that's the first question. Question 1 done in like 8 minutes. How you doing, Javante? I'm going to throw you some more points for being here, but ask questions if you got them. Anyone can ask any question. We can do something else in this. There we go. Protein bar. Add one protein bar. Add one protein bar. One protein. All one. It's probably like it has everything you need all in one. That's probably why they named it that. 833. Let's go out here. Number 2. Question 2. Okay. Very similar. This is the conditional display right here. And when you look at this, all you're doing is 321 divided by that, or the number right there. So you're just taking and going across the top row right here and dividing by the totals. Notice it says conditional, given someone's a college president. Actually, it's the lower row. I should have said that. I don't know why they do that. They're going to do that to us. So all you're doing is taking 37, dividing by the total. And we're just going to go through into every number. We're going to times by 100 and then delete the decimals. So that's 37 out of the 1053 college presidents think it's poor. We're going to times by 100, and we're going to copy. We're going to paste and make sure it rounds properly. Same thing we're going to do for the next few right here. 229 is the amount that think only fair out of the 1053 total. And then we're going to times by 100, even though we can do it in our head. But we're going to copy with Control or Command C and paste in. And that one also rounds to there. Next, we're going to do the 615. And we're going to do the 1053. Once again, just making sure you know how to do a conditional display right here, given someone is a college president. These numbers should add up to 100, so you can check your work if you want to see if it does add up to 100 afterwards, because you're doing it out of it all. And there's no did not knows when we get to that one. And there's that. And then 0. Make sure it rounds. Mine all rounded down. There we go. It might not add up to 100 because of the rounding down or rounding up. If you round down a whole bunch. I got some questions on Chapter 4 quiz. Yeah, let's do the next here. Let's do it. Drop them in the chat, Lindsay. And thank you for being here, Lindsay. Let's throw you 1,000 points just for being here. This one's tricky, though. Notice that it's going to remove the did not know columns. This one trips people up. It's a very good one that we're getting done right here. Because when you do this one, what we're going to do is we're going to take the information right here. Thank you, Lindsay. Working on some big problems. Drop the questions in the chat. We'll do them. So what they're saying for this problem is we're going to remove out for the U.S. adults the does not know. Maybe it's because the other group didn't say it. That's 57. So we're going to take 57 out of here because this number is going to get subtracted. I think these two groups are going to get combined into one right here. And I think it's good and only fair we combine together. I'll double check. But that makes a total, after we subtract out the adults they say they're not counting, 1087. All we're doing is subtracting out. Yeah, study reports load factors. We'll do it here next. Thank you, Lindsay. You jump in, you ask a question. We'll get it done next because you're here. If anyone says, wait, you didn't do my question, join in office hours. We'll do your questions. You just come to the links, check out the online for when I'll be online, and we do it. So we're just going to divide these numbers. We can do it right here on this screen. Right after this problem, we'll do it. So we're going to do 321 divided by 1087. Those have to be added, so we'll do 909 plus 748. That's the bulk of it, 2087. And And last but not least, 105 divided by 2087. Once again, they say remove out the do not knows, did not answer, or do not know, unapplicable. And they do say combined. Oh no, did I combine the wrong ones? I did combine the wrong ones. This last category has the combining. So it's the last category. I was doing it off my top of my head here. It's that last category. So 748 plus 105. These are the percentages associated with each group. Once again, we're doing a conditional display, so we're only focusing in on the U.S. adults. We are not using the information down below, down here. We're not using that. So we're only looking at that info right there. Just understanding how the problem is done, we're going to find this percentage, this percentage, this percentage. So I'm going to put this over here on the screen. I'm just literally doing the math you saw me do. And so we have 321 divided by our new total of 1087 and times by 100. As long as I have not made a math error, this one does have to round up. The only thing that can get you on these usually is math errors. 909, 2087 times 100. And once again, you should get about 100% depending on how it rounds up or down. This one rounds up to, so we could get the 100.1%. And then the last one, 478 plus the 105 divided by 2087 times 100. And that one does round up too. So we would if we had these up, get a little more than 100. And you can see right there, a little less. Sure, something seems weird. Let's go with it. Let's go with it. We did it. That's it. That's considered a tricky problem just because the way they ask it. Of course, they got to ask it in a weird way, right? Okay, let's go check out that question. Study does load factors. How's your day going, Lindsay? We're going to find that question for you real quick. It's on the quiz, right? Tap for quiz. Tap for quiz. Get it done. Tap for quiz. Load factors. Oh my gosh. Load factors by season. Pretty good in between classes right now. Nice. I think I found it. Tell me, be like yes or just say yes or no if this is it. Is this one it? Is this the problem? Just yes or no, and let me know. And I'll switch it up if it's not. Stat Tool 1, Chapter 4 quiz. Study. No, this is not the study. It doesn't say a study. Nah. You said a study or that one. It said load factors when I did it up, but it didn't say a study. Just grab load factors. Why is it moving that? See, it moves the little question thing. So I was clicked on it. If you see the number, you can tell me the number too. I can see all the questions. Some of these are tough, like the box plot ones. That's easy. I think we found it, right? Is this it? I think this is it, right? I think this is it. Nice. Okay, let's do it. And then tell me the other ones you're working on. What's up, Abby? Mewbot's here too, throwing your points. Okay, let's take a look. They are looking at the load factors, like how much things are loaded. Sure. And what we see is the full data set where there are some low outliers, and then we see the year by year, 2002 to 2019. And you notice there's an outlier here, but it would be more in the central part of this data. So it really matters how you divide data up if things are outliers. Like, think about this. Is it an outlier to run a mile in 7 minutes? Sure, if you're like 3 years old. Imagine a 3-year-old running a 7-minute mile. It'd be like, that's impossible until you see it happen. The context is what makes things outliers or not. In the full data set of everything, all the low things are outliers. But at the start in 2002, that was more like typical. The median is typical, and then the IQR gives the spread of the middle to 50%. Remember, the whiskers are not necessarily outliers. They are the min and the max. When there are no outliers, that would be the min right there. Be very careful. We've done box plots. You have to know this is the min, that is the max. There are no high outliers, even when you break it up by yearly data. So outliers are very context dependent. It's either A, B, or C, obviously. Data values that seem ordinary when placed against the entire data set may stand out when compared. Data values that seem ordinary, I've done this one a billion times. I'm like, don't mess it up, Brian. Data values that may seem ordinary when placed against 1 year's data may stand out when compared against data values that may seem ordinary when placed against 1 year's data may stand out when compared. Oh my gosh, the way they phrase this. I've done this one so many times. When placed against 1 year's data. Okay, I think it's this one. Data values that may seem ordinary when placed against 1 year data may stand out. And what they're talking specifically about is that one. That seems ordinary. Look, you see it's around 80. It seems ordinary down here in the full data set. So that value may seem ordinary when placed against see, now I'm thinking it's this one. Data values that may seem ordinary when placed against 1 year's data set may stand out when compared against the data for another year. It is kind of, it's either A or B. Yeah, it's B. I mean, A. Really? Wow. Just the way that's phrased. Wow. I know, right, Lindsay? This is all they're trying to get at. Why do they got to phrase it weird? Data values that seem ordinary when placed against 1 year's data may stand out. Let's see right here. Let's see what past Brian did on this. Surely I didn't mess it up that badly in past years. Here's a cool, fun thing you can do. If you go over here and you search, you can find other videos where I did this. Here's past Brian. There's my fantasy selector. Box plot version. I know, right? Here we go. Talking about side-by-side box plots. Wow, I did a much longer thing. Oh, I'm comparing them. Have I selected it? Wait, did I select it? When did I choose the answer? Surely I showed the answer is right. It's very important. Drop another question in the chat. We're just going over the, there we go, the 5 summary. Here we go. There it is. Oh, I got it first try. See, yeah, life hack. You can find many ones, like multiple reviews. Another question. I was on a streak. And I got one wrong. Medium length hair, Brian. I've done these questions so many times. Did I check answer and got it right? Did you check answer? Sugar is a major ingredient. Is that chapter 3 or chapter 4? That was the old fade we used to do. Chapter 3 or chapter 4? Which chapter? It used to be bigger, too. Chapter 4. Let's do chapter 4. Medium length hair, Brian. Medium length hair, Brian. Chapter 4. Okay, where is it? Chapter 4. Sugar is a major ingredient. Sugar is a major... Oh, this one's fun. We got this. Time to go. Let's just peel some points for Brian getting something wrong. Every once in a while, we're going to get something wrong here. It happens. Make the chat bigger. I'm just disappointed in myself. I don't really got any wrong, and then I got it totally wrong. Data's outliers, it's all context dependent. 2013, Stat 201, Chapter 4 quiz. Sugar is a major ingredient. Okay. Sugar is a major ingredient in many breakfast cereals. So you see adult cereals and children's cereals. What gives you a better view of shape? Histograms or box plots? So good review. When it comes to histograms and box plots, what gives you a better view of shape? We got kind of side-by-side box plots and histograms. What gives you a better view of the shape going on right here? It doesn't ask that, but it should. What gives you a better view of the shape? The histogram or the box plot? What really gives histograms? Histograms, you can see the bimodality to it a lot better. You can see the centrality of the data there. And we could do stacked histograms. We could stack like the adult versus children's cereal. And when they want the range of the data, you can see the range right here from 2 to 66. We're just going to subtract those numbers and get 64. The shape of the distribution, look at the histogram. Very bimodal, definitely bimodal. What aspects might account for this? It's definitely that there's either like high or low sugar cereals. That would encompass the range, but it's really that cereals are either like low sugar or high sugar. There's no like, do you want some sugar? It's like, do you love sugar or do you not like sugar? We all love sugar. Are all children's cereals higher in sugar than adults? So for this, we'd look at the min of children's cereal. which is right there, and the max of adult. And yes, and that's not a value of 66. That's telling you 66 is right there. So the lowest children's cereal, maybe they classify it by sugar. Be a smart way to do it. So all children's cereals are higher than all adult cereals. Although the ranges appear to be similar, if you look at from here to here, and we'll draw on this, why not do a little drawing? You can see differences in the IQR. What has a bigger IQR? Type C or A in the chat. And great job, we'll throw some more points here. What has a bigger range, C or A? What has a bigger IQR? I said range, but what has a bigger IQR? Because they both have similar ranges. So when you look at the ranges of the data, it's the min to the max. Min to the max is going to be here. This is the range of this group. So this is range, and this is range. Now, well, this is the range of adults, and this is the range of child. And it looks like, yeah, I said bigger, right? Nice job. That's the IQR of child, and that's the IQR of adult. And what does IQR show? The range of the middle 3%. It's another measure of spread. So it looks like, and great job, Javante. Let's throw everyone 1,000 points right here. So it looks like, although the ranges appear to be similar, adults have a bigger IQR, indicating more spread to the data. The adult data is more spread out. So although the ranges appear to be similar, the IQR is larger for the adult cereal. That should be right. And we've done it. Another 100. How many can we get done? Drop more questions in the chat. Just keep saying, hey, Brian, I got a question with this, and we'll do it. I'm drinking some sugar water. 78% of my sugar in one can. How much do you get over here? How much sugar in this? Sugar alcohols, 5 grams. Does that count? 1 gram of actual sugar. I ripped it over. So I've had 40 grams of sugar. Ha ha! We can do chapter 3 quiz. Is what you just ask. We do. That's how office hours work. You say, you drop usually the first few letters of a question in the chat, and we just do it. And if you're like, hey, Brian, you didn't get my question, just come to office hours, drop that question in the chat, and we do it. You just say, do this. It is your office hours. It's your time. It's our time down here. That's how it works. Okay, I'm going to play a different song. Play this song. Chapter 3 quiz. Chapter 3 quiz. We could go back and do chapter 3 homework. Chapter 3 homework. Should we do chapter 3 homework or quiz? I was on question 3 of chapter 3 homework. We did some of the tougher ones. But you can just say, do things from chapter 3 quiz. You can give a question. It's whatever you want. It's whatever you want. Wish I had a lot of Pokestops around my house. Pokestops. Pokemon. I'll do a chapter 3 homework question while we plan it out. We're almost done. We did 2 out of the 6 questions. The rain, no rain is what gets people. Oof, rain, no rain. Okay. Oh my gosh. The way they phrase some of these, and I want to point something out. If you get something wrong on the homework, you can redo it 1 billion times. No one's going to hear this. Wait, let me put it in the timestamp here. If you get something wrong on the homework, you can redo it as many times as you want. So please, please, please know you can click, you get wrong. With this in mind, you can, if the real differences, you can always hit try again. So there's always the try again button, and mine did it. It should be try again. Quiz? Yeah, tell me what's thing to do on the quiz. We'll do the quiz next here. So when you look at these differences right here, this is a stacked bar chart. Stacked bar charts are a display of 2 categorical variables. You see it down here, stacked bar charts. So this is a stacked bar chart, 2 categorical variables. What is somebody's diet and what is their political views? As people are, for vegetarians tend to be more liberal. Carnivores tend to be more conservative, or that's where you see conservatives start to take a larger portion. It is more evenly split according to this data. Once again, kind of made-up-ish data, probably. I hate made-up data. We need real data. So liberals are more likely. We're really looking at vegetarians are more likely to be liberal. So vegetarians are more likely to be liberal. Carnivores are more likely to be conservative. These are big differences. When you notice these gaps like this, the bigger the gaps, the stronger the association. One of my favorite examples is to ask somebody, which test would you rather take? And when you think about this, if we have the pass-fail rate of a test, which test would you rather take? Test version A or B? Someone type A or B in the chat for points. And I think then you'll be like, I get it. Would you rather take A or B? Which one would you rather? If you saw it, I'm changing one thing. Would you rather take A or B? So this is kind of like stacked bar charts. This is called a mosaic plot. A mosaic plot. This is a mosaic plot. Research group? Yeah, let's do it next. Would you rather take test A or B? Let me throw you some points just for being here, Peyton. Test A or B, which one would you rather take? A or B? Maybe you want to take the hard test, the one like, I got this. Test A or B? I'd rather take test B. A larger percent of students who, we're talking conditional, given someone took test B, they were more likely to pass it. And so that's a conditional distribution given someone took test B. Now, what does this information display down here on this way in the blue arrow? What does this blue arrow tell us? This is the marginal display of tests taken. Does anyone know what the blue arrow tells us, like the information on the bottom right there? What does that explain to us? What does that explain in a mosaic plot? So mosaic plots also give you a marginal display, the area in the margin taken up. What does that tell us? What does that mean? Any thoughts on it? Well, the marginal display displays one variable at a time. And with it displaying one variable, it lets us know more students took B than A about a 2-to-1 ratio. As in, if you look over here, this is about 30% of the area, and this is about 70% of the area, about-ish. As in, like, how wide is it along the axis? I usually do it as almost a 50-50 split. Well, A is a pretty tough test right there. Shout out to you. A has less students passing it. Given you took test A, there was a smaller amount passing than B. It is a frequency telling us how many occurred because it's counts of individuals in each group. Does that make sense, everyone? So there's more people who took test B, and a lot of people took test B and passed. In test A, more people failed who took test A because the top portion right there is the fail portion, and the bottom portion, we could do it like an orange color up here, so orange is fail. And so there's more people who failed who took test B. Okay, I think we got chopped a 3 quiz. A research group asked, is it these ones? Let me know if it's these ones right here. Is it this one right here? Peyton, is it this one right here? Is it a research group asked and then it does this? Just say yes or no in the chat. Because this one's in the homework. And we have the video for it right now. Once you complete the thing fully, it should have similar question or try again down here. Is it this one right here? Is it this one, Peyton? Let me know if it's this one. If not, okay. What's the full question then say? I'll try to find it here. Let me go find it. I'm going to do this one and type a little bit more about the question, then I'll try to find it. Unfortunately, a lot of the questions have similar wording to them. I'm going to do this one real quick, and then I'll find yours, Peyton. We'll do it here next. Okay, 29, 33. Question 4. We'll do all the questions. Okay, this one's about the Swedish man with the Swedish fish. This one tricks people a lot because it wants you to do the marginal display first. Doing this marginal display is like we just did with the previous question. It wants to know about what percent of men did get prostate cancer. So look down here at the bottom and you can see the marginal display of prostate cancer. And this is the amount that said, no, I did not get it. And this is the amount that said yes. Think of this as a candy bar. It's like a Twix bar. So this is the Twix bar. If I give you this much of my Twix bar at the end, how much of my Twix bar am I giving you? So this is my Twix bar. How much of my Twix bar am I giving you? If I give you that part at the end, how much of my Twix bar am I giving you? Anyone want to take a guess? Thank you so much. We'll figure that one. We'll find that one next. Javante says 10%. I think you're right, Javante. That's about 10% of my Twix bar. So that's what it's doing in the marginal display. It just wants to know what percent of the yes and what percent of the no. And there it is right there. So now it's asking which group had more men in it, and it's asking for the full mosaic plot in here. Now, this is tricky. I'm going to tell you what it's asking. It wants to know if this group right here, and I'm talking about that yellow sliver that I'm highlighting, or this group has more people in it. And I'm talking the yellow sliver because it's a little hard to, if I highlight it, well, I guess we do it this way. This group or this group. Now, what I want you to think about is this is bar 1 of gold. This is bar 2 of gold. Now, bar 2 of gold is a little thicker. But which bar of gold has more gold in it in terms of area? When we say there's more people in this group, we're talking about it takes up a bigger area, not percentage of that group. And MK, you're right. It is group 1 has more people in it. Now, percentage-wise, if you talk about within the yes group, then this is more within the yes group and this is less within the no group. So the second question we'll get into within the yes group and within the no group, where this one is just asking which one takes up more area or has more people. So the answer is the no group has more people in it, just because it takes up more area. So that did not have cancer. Now the next one is which had a greater percentage, and that is the group with cancer, the yes group. And we just showed that here visually a second ago by doing this. So the answer to the first question, or question B, was looking at the yellow area I have highlighted right there, saying 1 takes up more area, has more people in it than 2, which is larger this way, but has way less area when you think about it like a bar of gold. Imagine just melting this down into a bar of gold. That's a bigger bar of gold than this one, even though this one's a little bit thicker. Now, the second one asks which one has a higher percentage within their group, and we could zoom in really close here for you to see that in group 2, this is a little bit longer, taking up more area. Does that make sense, MK and everybody? This one usually tricks people. Question B says the yellow question, like using yellow guidelines right here, which has more area? 1 has more area. The next question, question C, says which takes up more area in their no or yes group. This one takes more area up in the yes group. So good question. Let's go find, wait, is it this one? Did we, no, this is A through D. Why do they keep doing the same thing? Is it, Peyton, is it this one, yes or no? I think you're going to say no. Just throw a quick no in the chat, Peyton, because this is A through D, so I think it's not. Okay. Why do I got to do like the same question a billion? Yeah, that's what I thought. Peyton, thank you so much for being here. Let's go find that question. Let's go find it. They got to do like the same wording. It's like they couldn't come up with new things. Come on, Pearson. Come on. What you doing, man? Why you got to do that? Okay. It's got to be A through C. That's a good quick one right there. Plus, we got to do the rain, no rain. Ooh, I hate these ones. Ooh, I hate those. You want to watch me get something wrong again? I'll get something wrong right there on those. Don't tell anybody. Like, this guy can't do stats. A through D. We should be getting close. A through B. A through... No, this is different. It's A through C. Payne, did you see it? If it's A through C, I don't see it. It's A through C. And a research group asked, tell me if you see the number. That's A through B. Where is it? If you see which number it is. A through D. It's got to be here. If anyone else has any other questions, let me know. We're trying to find Peyton's question. No, it's not it. It's got to be here. Peyton, I'm confused. Do you want to send me a screenshot of it, Peyton? Why would it... I can show completed in it. Shouldn't make an extra part. I'm very... Wait. No, wait, this is... Did you see it, Peyton? This doesn't say A through C, though. I am so utterly... If you drop a screenshot of it in the Discord, I'll look at the Discord. Can you drop a screenshot of it? Pew Research? Yeah, let's do that. Rate their job. Oh, that's the one... I think we might have done that, Lana. I don't know. We can't find yours, Peyton. Did you see the number here? Which homework number is that, Lana? We've probably done it. So we've done a lot of the homework already. I'll show you the timestamps here. We've done the first part of the homeworks. So we did homework 1 and 2 already. I might just finish off the homework, and then it'll all be in this video. And then we're going to try to find Peyton's. I'm so sorry, Peyton. I have no idea what the question's... Question 5. Oh, let's do question 5. That's what we're on. Okay, let's do question 5. Peyton, we'll try to find this. I'm so sorry. I have no idea. Why they got to make the same question like a billion ways? It's in homework 3, right? Or did I mess it up? Because I think that's the only time they use that wording or phrasing. Question 5. Okay. Is this A through D? A through D? We're trying to find A through C. Okay, let's get this done. Okay. 36, 33. Thank you so much, everyone, for being here. I want everyone to get their work done, and I want to find your questions. Peyton, I'm 35,000 points. I feel really bad that we can't find this. We're going to find it, though. So there's 5,000 points, Peyton, just for being here. I want you to feel like you got something. That's the biggest points button I can hit, so now I got my cool cards. Hey. Okay, let's do this. Okay, Pew Research Center, investigating what people think about colleges. We got a mosaic plot. So if you look at this mosaic plot, they interviewed more who? Adults or presidents? So type A or P in the chat. They interviewed more adults or presidents? What do you think? They interviewed more adults or presidents? We're going to talk about some terminology here. So A or P, adults or presidents? They interviewed more adults. Great job, Javante, right there. Thank you, Peyton. Peyton, another 1,000 points. We're going to go look at that here in a second. I'm going to go to the Discord. So this is the marginal distribution showing us the amount of adults and the marginal distribution showing us the amount of presidents. It's about a 2-to-1 ratio, like 2,000, 1,000. I think they tell you the numbers. And it's clear that the vast majority of presidents think that it's either a type of letter, what? Fair, poor, just type of, most presidents think it's a what value? Most presidents, within the presidents, most presidents think it's a what value? Within the presidents. Most presidents think it's a what value? Within the presidents. They think it's either good or excellent. Great job right there, MK. So they think it's either good or excellent within the presidents. You get a lot of, within here, a lot of this right there. Within the adults, there's a bigger portion that think it's only fair or poor. So you get a lot more of this. There's a lot of people think it's good or it's less excellent. So notice this, Mubot saying hello. Hello to you too, Mubot. So this is the conditional, given someone's an adult, given someone's a president, what do they think? And there is a relationship here, it seems. So from the mosaic plot about what percent were college presidents, I think it's kind of nice. We're just going to take a guess, but we can also find the exact number. I'm going to type in 33%. If it doesn't like it, we'll fix it. It got it. You can actually find the real number here by adding these numbers up for the total amount. 2143. That's how many adults there were from the top of the screen, plus 1055. And then you can take this number here, 1055, divided by, and you can see the question has a little bit of leeway. So it's about a third. So, but you can also find the exact math, double check your math, and it should be right. Is it easy to see there are more U.S. adults who said college provides excellent or more presidents who said excellent? Yes. And this is talking about how many there are. So when it says, well, the answer is going to be no, and this is a weird one. It wants to know, is it easy to tell, are there more people? So we're going to do our bar of gold trick. You ready? I want to know, if I turn these into bars of gold up here, which bar has more gold in it? This bar of gold 1, or bar of gold 2? Which bar of gold, if you were to melt it down, has more gold in it? Bar of gold 1 or 2? What do you think? So bar of gold 1 or bar of gold 2? Are they it's hard to tell. Bar of gold 1 or bar of gold 2? Well, I like the question mark, and I like already we have a disagreement. The answer is it's hard to tell. Does that make sense? Because when it says which has more people in it, it's not asking percentage-wise, which will be the next question. This is like the Swedish fish question we just saw a moment ago. So it's asking which one has more people in it, which is the area of it. So it's just saying which has more in it. And there's more adults, but there's a less percentage, but it's asking total people in it. So it's actually hard to tell. So due to the differing sizes, it's not easy to compare the two rectangles. It's not easy to compare the areas because it's saying which one has more area to it. But here's the thing. Which one has a greater percentage? So this is just like the previous homework question we did. 1 or 2 is a greater percentage within their group. So I think everyone's going to start shouting and answer this one. Is it 1 or 2 that has a bigger percentage within their group? Is it 1 or 2 that has a bigger percentage within their group? And that's the conditional, 2. And that's conditional right there. I think I said conditional. And okay, no question marks on that one. That one's a 2, right? So this is, given someone's a president, they're much more likely to have an excellent view. I should probably change the color down here to this because we've changed the color. Given someone's a president, they're more likely to think it's an excellent view versus given someone's an adult, they're less likely to have an excellent view. And that goes to proportions right here. So this is much easier to see because the proportion of each rectangle, and when we say proportion, we're talking about in its respective group, like of the presidents, the proportion is much larger. And that should do it on this one. Boom! I tell you what, oh, there's one more. From the mosaic plot, do you think there's an association? Oh, yeah, because they're very different. When the blocks don't line up like this, the more they don't line up, the stronger the association. I should do that in a different color right here. We'll do it in some yellow. So the bigger the gaps right here, the stronger the association. And because there are big differences in the proportions, there's definitely a stronger relationship. This is the last one on the homework, so let's just knock out the homework and everyone will have it done, and then we'll do some more quiz stuff. But who's basically got the homework done now? And once again, tell people, be like, he just does the full homework here, you know? Why not? I can't do everything, but I like to explain it while we do it so you can come back and review and hear key terms. Like, what's a key term for this one? A key term is multivariate mosaic plot, because it's no longer bivariate. There's 3 variables right here. We'll never put this on the test, so why is it in the homework? I don't know. To confuse you. We got 3 variables here. We got omnivore, carnivore, vegetarian. We got liberal, moderate, conservative. And the best thing to do is to break it up into individual mosaic plots here. So we'd have a mosaic plot here for the liberals. And then we'd have a mosaic plot here for the moderates. And you'd have a mosaic plot here for the conservatives. Okay. What do you notice about men? Men are always a little bit more likely to be what? Men are always a little bit more likely to be what? I'm highlighting it with the green right here. No matter what the group is, men are a little bit more likely to be what? Highlighting it with the green. No matter the group, when you compare female to male, female to male, female to male, or you could also think about it this way, men are less likely to be what? This compared to females, pretty much across the board. What do you think? Men are more likely to be carnivores, females are more likely to be vegetarians, according to this data. Most people are omnivores. I mean, unless you're like pure carnivore diet, drinking some bone marrow, hanging out with Joe Rogan, just, I don't know, tomahawk steaks all day. It's people who do that. Hey, you do you. It's not for me. I'm drinking my Coca-Cola. What do I know? It is good, though. Okay. So, Coca-Cola. And with this in mind right here, what do you notice about the amount of female in each group? So I'm going to highlight this in a light purple. And female compared to male here versus female compared to male here. Notice that as we go down, chapter 3 quiz, we got that next. You got it, Abby. What do you notice? The percentage of female is increasing or decreasing from the first group right here, we'll call that group 1, to the last group over here. The percent of female is what? Let's do it. You got it. The amount of female is increasing or it's decreasing. So it looks like there's more females in the liberal category and more males in the conservative category. And you're seeing by, percentage within the group. If you look at where I marked, that's about a 40-60 split versus over here on the far side, it's this side over here. That's like a 20-80 or something. It's smaller. And we just went to the extremes to point it out. So let's echo that in the data right here. And the first thing it says, are there more men or women in this survey? Well, there's always more men in each group. So there's definitely more men, and that's seen in the marginal display. So the widest bar is labeled M, and those are in the It's each bar. Total areas of the marginal bars. I clicked way too quick. The total areas of the bars labeled M is larger, yes. It's not just the widest bar. It's each bar is wider. I was thinking it's wider, but it's a homework. The marginal displays tell us what's going on. Does there appear to be an association between politics and gender? Yeah, because as you go across, this is the purple one right here. There's more female here and more male on the other side. There appears to be, this is where it's mean. It's either weak. I think it's weak. I don't think it's strong. Politics, females in each group, politics tend to be, they get smaller as you go from towards conservative. And it's strong, really? Calling that strong? That is very subjective. That is very, very... I would have gone with moderate, and that's the problem. There's definitely something going on, and strong, weak, moderate are all subjective words. There's definitely a strong association here if we look at politics and diet. When you go across and you look at liberal to conservative, conservatives are way more likely to be what? Type a V, O, or C in the chat. Conservatives are way more likely to be what? Type of V, O, or C in the chat. Conservatives are way more likely to be what? Which one? Carnivore, exactly. Doesn't mean they are. It just means they're more likely. That's what association is. There's a strong association as you go towards conservative includes more meat. Does the association between politics and diet seem to differ between men and women? Yes. As we pointed out right here, women don't have this big carnivore jump at the end. I'll highlight just that. Men have this huge, conservative men just have this big carnivore jump at the end. And liberal women have a much more higher vegetarian. So the difference in proportion of vegetarians between liberals and conservatives is, okay, proportion between vegetarians between liberals and conservatives is larger for women because women have that big jump right there. So that difference is bigger for women. And the carnivore difference is bigger for men. And that's what we're seeing right here. This is the difference between conservative women right here. See, this is men. It's not as big. And then this is conservative men versus liberal men right there. And there's a bigger jump. So here's the one jump, the big jump for women, and the big jump for men right there. And that's the big jump. They're not as big for other groups. Like if we do the other groups like this, it's not as big. I mean, there still is a jump, but it's not as big. So that's what they're pointing out. That's what it says down there. Good job. That's what associations are. It's when knowing one thing gives you information about another. It doesn't prove it. Great job on all those answers. Let's go do another homework question. Chapter 3 quiz. When do I have my... I'm going to teach for a little bit here. Google Calendar. I'm almost afraid I'm going to like miss class. 2:30. 2:30. How's everyone doing today? We already done the full homework. I want to say a huge thank you. Semester's going really well. Really proud. I'm always trying to reach out. If I email you, it's because I want you to do well in the course. I'm always afraid students will be like, "Why are you emailing me?" But I've had a few students say, "Thank you, Brian. Like, I really appreciate it." I always email students I want to do well. I email everybody. I want everyone to do well. That's my goal. Is to like. I think I reach out to the Brians. Like, I wasn't always the best student in class. I'm trying to find your question right here as we do this. Does anyone ever watch Malcolm in the Middle? Throw a yes in the chat if you ever watched Malcolm in the Middle. There's a really famous episode. I'm going to put it in the chat even. We'll mention it. It's so perfect. This is so good. Okay. I'm going to explain this. Yeah. Okay, this is like the best episode ever. This copy video at current time. If you haven't seen this episode, it's so good. And there's something that rings true to me right here. So what happens is Lois is talking about her sons and she's like, Malcolm will do fine. Like she's like, Reese is the one I have to help. Like Reese is the one, like she's like, Malcolm, he'll make it. I have to help Reese. Like Reese is the one, and this teacher's just trying to like make Reese's life worse. And she's like, he'll do fine. And he's like, you won't. Check it out. He's like, you wouldn't like let one of your children suffer. And she's like, it's so good. One of the best scenes in Malcolm Middle ever. But yeah, it's like, but this moment where she's like, she has to help Reese. Like, that's what I think about a lot is I'm here to help students who need help, who, you know, will benefit the most from me helping them. So that's what I think about in education. It's like some students will go through education fine, but as a teacher, you're there for the ones who needed the help. Okay, we need some help. Let's get serious. It's just such a good scene. It's so perfect. Okay, I got the quiz up. Okay, we're trying to find students in an introductory stats course. Students in an introductory stats course. Students, what are they doing? Oh no, not these. Not these. The wording. The way they word it. Should we do a bunch of these? Should we just knock them all out and do them all? What do you say? We can do it. We can get a lot done if I do it. I'll show you a quick way of doing them. So we're gonna try to do every single one of these. The way they word these get a little bit weird, but let's understand how to do each one and look at the math. So let me mark this in the notes. 5113 and chapter 3 quiz. Stat 201, chapter 3 quiz. Students in introductory. All versions. Okay, we're gonna do all versions of this. I'll show you how. Here's how. Boop. Okay. First question asks, what percent of the class is male? Is that a marginal or conditional distribution? What percentage of the class is male? Is that marginal or conditional? What percentage of the class is male? Is that marginal? Just type MRC in the chat. What percentage of the class is male? Is that marginal or conditional? It's marginal. Great job, MK. MK, you're on fire right there. Make sure during class, join in. I'll mod you during class. That's when we mod people up. So to figure out what percent of the class is male, you type 124 divided by 207, and there's the number right there, times by 100. What percent of the class considers themselves conservative? That's also marginal because it's just one thing being asked. 34 divided by 207. Notice it's not a bivariate idea. It's just one thing we're asking, like what percent is conservative? So you're just asking about one variable. That's what marginal is. What percent of males? So now we're going of the males, what percent consider themselves conservative? That is conditional. So 25 divided by the 124 right there. There's the answer. Oh, you are MK? MK, text me right away and next class, I'll make sure. MK, let me throw you another 1,000 points, MK. Thank you so much. Yeah, I don't mod people during these streams because anyone can join. I mod people during class. So thank you, MK. Glad you're here. What percent of students in the class are males? Now, this is a weird way to ask it. It's asking what percent of students, of all students, meet these two categories. So it's what percent of all students meet the two categories to solve this. Conservative males are 25 out of the 207. It's a very small change in wording. And there's the answer right there, 12.1. Let's look at the next one. This one right here has you find the conditional distributions right away. So it's very similar. It's going to be if somebody is female, how would you break down each one of these categories? So does that make sense? Like, how is this 43.5 found? So if somebody is female, what's the probability they're liberal? Someone type the chat point, the things in there. Showed up to class. Nice. Abby, great work. How do we find this first one right here? If someone is female, the probability they're liberal. What is the math for it? Because if you get the math for that one, you get the math for all of them. So it's if somebody is female, what's the probability they're liberal? So you have to do of all the females. So it's a conditional distribution. Visually, it'll look like the following. We're showing how to get every one of these. So you'll see if you have a version. So it's if somebody is female, what's the probability they're liberal? And actually, you don't even look at the other stuff. You don't need it. If somebody is female, what's the probability they're liberal? How do we do this? How do we get it? If somebody is female, the probability they're liberal. This is how you do a conditional display. You don't look at anything else. Nothing at all. How do you do it? If somebody is female, what's the probability they're liberal? Conditional means you look within one group across one row or one column, and then you do the percentages respective to that total. That's what a conditional is. Given someone is female, what's the probability they're liberal? Who's got the math? 1,000 points on the line right here. Get some more points. Given someone, you guys are basically guys, gals, pals, all tied for points right there. I say guys for everyone. I'll be leaving people. My mom and my aunts will be together, be like, bye guys. From New York. How do we find this? Given someone is female. Nice job. Points in the chat, Javante. Boom, boom. So that's how you do all of them right here. It's going to be the same mathematics to get each one of these categories. And then just make sure to round properly. Great job, MK, also. And then do the same down here for males, where you're just going across like 52 divided by 118. And just make sure to carry your math properly. Great. Just divide by the total. Given someone is female, out of the females, what percent are liberal? I don't really like the way they phrase this. Be very careful. They want it broken down by this variable. So females, you can see there's less conservative percentage-wise. If you do each of these percentages right here, where we have males, you can see 20%, which is, this is 10, 20, 30, 40, 50. So that's basically 20-ish%. So it's going to be this group. Just make sure your percentages line up. It's going to be female and male if this is the version you have, where it says to make it this way. And there does not appear. Oh, they do not appear to be independent. I was going to say there does appear to be an association, which means they do not appear to be independent. Independent means that there's no association. Dependent means that if somebody is male or female, they'd be more likely to be one or the other. If somebody is male, they're more likely to be conservative. If someone is female, they're more likely to be moderate or liberal. It's not a one-to-one thing, but there is a higher percentage of males who are conservative. You can also see that up here about twice as much. And there is significant differences between at least one group, especially this right here. I think we have maybe 2 more versions. Let's check it out. This is the same idea, and I hate the way they say this. Be very careful, produce a graph comparing the conditional distributions of males and female among the 3 political categories. So notice the small change in wording, where this one says make a graphical display comparing the 2 distributions. So when it says the 2 distributions, you need to pick this one right here. And when it says comparing the 3 political groups, if your question says that, you need to do this. So everyone see that small change where this one says compare the 3 political groups? And this one doesn't even have you do the percentages. It has you compare them, where you can see conservatives. If you look at the 32 people who are conservative, you can break that down where 8 are female, and that should be about 24% or so. So we do 8 divided by 32, and it's 25%. I should have just realized that 8 divided by 32 is 25. So that is 25% right there. And you can see it. So just double check your math, and you should be able to tell, well, it's about 25% right there. And then you divide 8 by 32. So technically, this display is doing the conditional this way. It's saying, given somebody is conservative, given somebody is moderate, given somebody is liberal, and it's breaking it down that way to turn it into the percentages, where we'll make this smaller here. Go to our light purple. And 25 and 75 for this group, respectively. You need to do it for all of these. Yeah, we'll do the film one next. You got it, Javante. You got it. And comment briefly, the proportion of females and males for conservatives is significantly different, showing that there is an association. There's an association here. There might be one more of these. That's got it. There's the rain, no rain. But that's all versions of it. The rain, no rain, we probably need to do that one to end at least. The rain, no rain gets people. Let's do the films. I think it's a little further back. I think it's question 11. Oh, no. Thank you, Joante. Here we go. Then we might do rain, no rain next, because that's a very commonly asked one. I've already worked it 3 times, like in office hours. Don't worry if you asked. It's like the top question every semester. Like, wait, how do you do this question? It's a good question. Like, some questions I think are confusing, but the rain, no rain, I really like. The famous rain, no rain question. I don't know how to spell summarizes. Summarizes. 50, 20. Oh, let's take it up. Oh, here we go. So you have to be very precise in your wording with this. This is a contingency table. Contingency tables are a bivariate display of categorical data. Notice it's green also. There's color coding this graphic. But 2 categorical variables can be displayed in a mosaic plot, contingency table, side-by-side bar charts, or side-by-side pie charts. Yeah. So with that, we have to look at what each question is asking and be very careful on how we answer it. So let's look at the first one right here. For the first question, what % of these films were rated PG-13? So that's a marginal display. It doesn't give us a, given this film is this, what's the probability of this? That's how conditional sounds, like what's the probability of this given this? So PG-13 is just going to be looking here, 291 out of the 1529 total. 291 out of the 1529. 291 out of the 1529. Please tell me if I make a math error. I make math errors every once in a while. There's hopefully not a math error in that. What % of these films were PG? What % of these films were PG-13 rated action movies? So that's like a combo. It wants to know what % of these films, like all films, are PG-13 rated action movies. So now we have to go in and look at, of all the films, PG-13 action films. And that's 35 out of the 1529, because it's like out of all the films. 35, 1529. So it's like 2.1%? 35. 2.3%. It's a guess. What % of PG-13 films? You see, that means we're going conditional on this one. Does that make sense, Javante? Like, what % of the PG-13 films were action movies? So now we have to go conditional, and that's where we got to be careful. Because it's what % of the PG-13 films were action films. So we go of the PG-13 films, what % were action? And what is the math going to be? Who knows the math? Type it in the answers or type it in the chat. What % of the PG-13 films? And I'll solve it here. What % of the PG-13 films. Because that's conditional. Like, given something is a PG-13 film, what's the probability it's an action? Going to class. Glad I got reminders. What percent of the PG-13 films? What's the answer? I saw it at the corner of my eye. There we go. So 12-ish percent. Around 12, right? And then what percent of action movies? Notice how it changes. What percent of action movies were PG-13? So that's different right there. So now it wants to know what percent of action movies were PG-13. What's the answer to this one? What percent of action movies were PG-13? I'm going to, yeah, I think like 34.8. I'm going to take a guess. 34.8. Did I get it all right? Oh, did I get that last one wrong because of that? Or did I get another one wrong? 34.7? No way is it mad by 1 decimal. No way. One decimal. 1 decimal. Does that make sense on the last one, Javante? What percent of action movies are PG-13? It's the wording's very specific, like 1 decimal. 1 decimal. I did it in my head. I'm gonna go 1 decimal off. Well, we might end with that rain, no rain question. It's a very famous one. It was back here, like number 13. Where's the rain, no rain? Pew Research? We might have done all those. I think we've done almost. Did you find it, Peyton? Is it the Pew Research Center? Did we? I don't. Tell me if you see its number here. You posted, Peyton, right in the Discord. Okay, Peyton, you're here, so we're gonna. Okay, let me go look in the Discord. Thank you, Peyton, for posting it. Here, I'm looking at it now. It has A through D. I gotta find that. Okay, I think I'm blocking my screen right now, but you can see I'm not looking at anything crazy. Like on the, I have like emails and stuff. What percent have a poor value is the first question. I'm like gonna like. Sometimes it changes the question when you answer it. Like there's different versions. How is it possible that you could have a question I don't have? Well, it's not this one. We've seen this. I mean, I could just take the question you have and do it. Wait. It's this one. It's this one right here, right? I think it's this one, right? I'm looking at yours. Type yes or no, Peyton. Is this yours? I think it's yours. We finally found it. We did it. I think this is it, right? Tell me if I'm wrong. I think I found it. I think I did. Okay. Let's say 104. 104. Yeah, it'll always use different numbers. Yeah, no, that's a good point. Thank you for noticing. It'll have different numbers. No, it's a research group. Okay. So the first one right here, what percent of college presidents think that it's a poor value? So how many college presidents are there? And then, so it tells you how many college presidents. So what percent of the college presidents, what's the math going to be paid? And help me out with this one. So it says, of the college presidents, what percent think it's a poor value? So what's the mathematics we're going to solve? So of the college presidents, what percent think it's a poor value? Of the college presidents, that's how many there are. What percent, if you add up across here, you'd find 1054. So what's going to be the math? Of the college presidents, what percent think it's a poor value? So tell me the math right there. Of the college presidents, what percent think it's a poor value? Nice job, Peyton. So that's going to be 28 out of the 1054. And we're going to times by 100. There we go. Do the next one. What percent of the U.S. adults think it's good or excellent? So we're going to add these two numbers here and divide by the total. And this is a conditional distribution. Given someone's a U.S. adult, we're going to add up the good or the excellent and divide by the total for U.S. adults. Given someone is a U.S. adult, what's the probability they think it's good or excellent? It's 40% when rounded. And then given someone's a college president, we'd add up these two numbers and divide by the total. Remember, these are conditional distributions because we're saying given somebody's a college president, 622 thought it was good, 181 thought it was excellent, out of the total 1054. Conditional distribution, given someone's a college president. Are these big or small differences? Just type big or small. I'm going to give you 40% of the cake or 76.2% of the cake. What do you think? Are those big differences? Big or small? 40% of something versus 76.2, which means 40% of U.S. adults thought it was good or excellent. Meanwhile, 76.2% of of college presidents thought it was good or excellent. Let's say the college presidents are much more likely to think. College presidents have a much better opinion, and they're college presidents probably for a reason. This last question is kind of weird. Not a big fan of it. If you take right here and 4.61% of U.S. adults think it's an excellent value, we can look at 98 U.S. adults set an excellent value out of the total 2127, which is the 4.61% when rounded. And that's probably a reasonable estimate. It doesn't mean it is this. It's not going to be exactly that. It's just a reasonable estimate. Yep, the quiz is paused. You can come back to them, and if there's an issue, let us know. Reasonable estimate. Well, I think we got a lot done today. We got a good bit of the quiz done. Yeah. A research art. Yeah, let's do that. We'll end with that one. Let's do that. Let's end with that one. This will be our last one here. A recent article in the Geophysical Letters. A recent article. Thank you, Abby, for being here. We've done all those. It's chapter 3, right? Tell me if it's chapter 4. Here we found it. It's chapter 4. Then I'd have to switch to the other thing. Thank you so much. Tell everyone in class. I'll probably be like, come to office hours and do work. Tomorrow's gonna be a bit of a weird day because I have a meeting. There's so many meetings. I put my office hours down as a maybe because like you have to put down if you're ever like kind of available. I can't go to meetings during class. Yep, so many things. What percent of estimated deaths were attributed to causes not written here? So they're giving us the breakdown of causes: 30% heat, 1% flying debris, 0.2% cratering, and 0.17% earthquake. So they're giving us the breakdown. Let's add these up. 30 plus, that's not 30. 30 plus 1 plus 0.2 plus 0.17. We're going to copy this and do 100 minus it. And so it's 68.63. Type an integer, do not round. Let's hope it likes our numbers. It's weird numbers. Looks right. Now, here's the problem if you graph this. Because of these percentages where something's like 30%, you're going to have like 30% and then 1% and then 1%, and then 0.2%. It's going to be so hard to see these bars. The bars are going to be dwarfed. And then you got the 60. It's ridiculous. So the numbers are in different magnitudes. Display of two largest values would not show the two smallest. Yeah, it's going to make it really hard to see what's going on with really what is going on. That's not the answer because all numbers are percent. No, I feel like I made a mistake on this, which I'm looking at it and thinking, how did I make a mistake? Who sees it for 5,000 points? I know what the answer is. Who sees it? 5,000 points on the line. Yeah, it's easier to see why I got it wrong now. If you notice, I subtracted off the 60 out of it. Who sees it? 5,000 points? How did I not see that? Because I read it too fast. Because it's the end of office hours. No one sees it? Points on the line if you saw my error. If you ever come to office hours, you get some points. What error did I make? This was my answer, and I got a 50. No! Because the error was created. I don't want to say it. Someone might be typing it. I'll give it 5 seconds. I'll give Jonty points just for being here. No, I want someone to see it. Oh, no, it's all right. We're subtracting. We're adding up what percentages are given to us. I didn't see the 60% right here. You should have added up the 60, 30, 1.2, all those. You add all those up, and you'll get 91 point something. So that's what I did wrong. I didn't. What I should have had, I'll show it, 60, because 60% plus 30% plus 1% plus 0.2. I just didn't see that percentage. Then you subtract this from 100. There we go. Does that make sense, Abby? I just missed that it said 60%, and I was like, man, that's a lot of stuff not listed. I was kind of thinking that in my head. I was like, 60% not listed? Yeah, so that's what it was. And I was like, I know the bottom one's right. I've done this one a lot. That if you have bars that are so big, you know, like 60%, so it'd look like 60% of the total, 30% of the total, and then the bottom bars are going to be like virtually impossible to see due to the magnitude of the other bars. So it's like really hard to display stuff like this if you have like 0.1% compared to 60%. That's how it sounds. 0.1%. 0.1%. Okay, with that, remember we'll do some more office hours. I might try to find special time for office hours tomorrow. I might do it after classes and stuff. But until then, bye for now, everyone. Bye.